video, I'm going to be going over the textbook questions from the previous lesson about extrapolation and interpolation, as I've received some emails to assist with you guys answer some of the questions. So before I do that, I do want to quickly go over the differences between extrapolation and interpolation. We discussed that yesterday, that interpolation is an estimation method where you're trying to find the value that it lies in between two known values. So in this case, what that essentially means is, if this is your data set over here, this is the range of all data set. It falls under these limits over here. And when you're interpolating, what that means is you're trying to find out a value that's contained inside here that's not part of the data set. So for instance, you might be trying to find out what is the sales generated when the temperature is 21 degrees. Another example is, I want to find out what is the sales generated when it is 13 degrees. Notice that all these values lie within the data set. So this is an example of interpolation, whereas extrapolation is trying to find out values that lie outside of the data set. Now, if you guys remember, we said that these two methods have different levels of reliability or accuracy in this case. So when we said that estimating values using interpolation is a far more reliable method, because values that lie within the actual data set follows the same general linear trend. So if it's a positive gradient, it follows the same linear trend. So let's say we're trying to find out the number of what is the temperature when there are 25 chirps in this case. So this lies within the same data set, so it does follow the same linear trend. However, in contrast, when you're estimating values using extrapolation, this is not a reliable method, as it assumes the data values found outside data set follows the exact same linear trend. So let's just say, for instance, what is the temperature when the number of chirps is equal to 10, in this case of here. Now, based on our graph, we assume that it would be, roughly going to be 42. However, that might not be accurate, because what might happen is that when it's outside the data set, it might not be linear at all. It might follow this particular dotted line instead, as opposed to the straight linear line. So if that was the case, then and we were doing 10 lies over here, so therefore it should have been like, let's say 28 or so. So again, you do really need to know this, because many short answer questions ask you, is this particular method a reliable measurement? Let's go through over the first question, and I've got the calculator on the left hand side so I can show you the way that we would answer the question. The first question reads, a study on the growth in height of a monkey in its first 6 months is assumed to be linear. Given the data shown, find firstly the equation describing the relationship between the two variables. So what we need to do first is we need to identify what is the extraneous variable and what is the response variable. We said the extraneous variable is, not extraneous, the explanatory variable is the variable that influences the numbers of the other variable. So in this case, you always ask yourself, does the month or the time from birth influence the baby's height, or does a height influences the month after birth? In this case, there's only one correct answer. It will be the month from birth, so the time after birth will indicate how tall the monkey has actually grown. Or so therefore, this is your explanatory. And therefore, we said that anything is on that is explanatory variable is always going to be along the x-axis, and therefore this is going to be the response variable, and this is going to be that's going to be along the y-axis. Once you've done that, what you need to do is now put all the values inside of your Excel spreadsheet. So you click this over here. You therefore name your variable. So I'm going to say month. I'm going to say height. Put all the values in, so that's 1, 2, 3, 4, 5, 6. Do the same thing for the other column, so that's 15, 19, 23, 27, 30, and 32. Once you've put all the values in, then press the on button, and then we need to click on the calculator icon over here. If we do this, the next step is we click on menu, followed by statistics, stat calculations, and make sure you press the fourth option, not the third option. So click on the fourth option over here. Now, the reason why we had to identify which one's the variable, because this will influence the values of your gradient and y-intercept. So this over here, x, we said was the month, so that's this. Y is the response variable, so that's going to be your height. click OK, and therefore this is going to give you the answer. So in this case over here, since we know that the equation for any straight line is y equals to a plus bx, so this over here, we now all we need to do is just insert the values in. So therefore y is going to be equal to a is equal to 12.3, 12.13, and I'm just going to round it to two decimal places for this question, plus b is equal to 3.49 when you round it to two decimal places, x. So therefore, now this is the answer, but what the question wants you to do is you want to use the actual variables from the question. So instead of using y next, let's use the actual variables. So therefore, your y, remember, represents this one over here, so it's going to be height. So it's going to be height is equal to 12.13 plus, I'm going to use brackets, but you don't have to at all, 3.49 multiplied by x, which means the month from birth. And therefore, that is the answer for part A. Now for part B, it's asking you what is the rate at which the monkey is growing. So the rate, in this case, whenever you see the word rate, that is simply asking you for the gradient. So in this case over here, your gradient is the number before the x, so it's going to be 3.4. So to answer part B, that's going to be 3.49. And for part C, it's asking you what is the height of the monkey at birth. So therefore, that's asking for the y-intercept, and this value over here is the y-intercept, so C is therefore going to be equal to 12.13. Make sure you do include the units, so height in this case is in centimeters, so it's going to be 12.13 centimeters. Let's check to see whether our answers match the answers from the textbook. So 12.13, 3.49, and yep, we got everything correct. All I did was just forgot to include the units for part B, the gradient. Now, how would you find the units in this case? Well, remember the formula, the gradient formula is m is equal to y2 minus y1 over x2 minus x1. If you recall, that was the formula to calculate the gradient. In this case, y, the units of the for y2 minus y1 is in centimeters. The units for the x2 minus x1, that's going to be in terms of months. So therefore, the units for the gradient is going to be centimeters per month, which is what the answer also had as well. Let's move on to the next question. Now, the next question is pretty much identical to the first question, just obviously a different data set. So if you can follow the same steps that I've carried out in question 1, you should be able to get the answer for question 2 as well. Now, question 3 is just slightly a bit more different. The question reads, using interpolation, so this is a method finding the values contained within the dataset, predict the height of a 10-year-old boy. Okay, perfect. So what we do again is we need to identify what is the explanatory variable, what is the response variable. So does age influence your height, or does your height influence your age? Obviously, your age is going to determine how tall you are going to be, not the other way around. So this over here is your explan, and that is plotted along the x-axis, and this is your response variable, so therefore this is going to be plotted along your y-axis. Now I'll do the same thing where I need to add all the values into my Excel spreadsheet. So I'm going to click on the spreadsheet over here. This time this is going to be age, this is height, but I think I've done height already. See how it's bolded? I have to either close all the other tabs or rename this something different. I'm just going to rename this because I'm lazy. So I'm going to say heights in this case over here. So I'll put 1, 3, 4, 8, 11, 12. Put all the height in. So that's going to be 65, 82, 92, 140, 157, and 165. I then go on to the calculator icon to therefore find the equation for the line of best fit. So I click menu, statistics, stat calculations, linear regression line. The age is going to be the x. And remember how we plotted what in the other question we use height. In this question I've made it different. I've said it was heights. So make sure you choose the correct one if you didn't delete the other page. And then click on OK. This is the formula over here. So therefore, y is going to be equal to a. So a is 56. I'm going to round it to two decimal places. 03 plus b, which is equal to 9.35x. Now remember, always write the variables instead. So therefore, your y was your height. So it's going to be height is equal to 56.03 plus 9.35 multiplied by the age. So that is not the answer yet, but that is our equation to describe the relationship between these two variables. The question wants us ultimately to predict the height of a 10-year-old boy. So once we've got the actual equation, it now becomes a lot simple for us to get the answer. So you want to find the height. The height is the y value. So you want to find out what is y when x, or when the age is equal to 10. So I'm going to sub age is equal to 10 to find out my height. So therefore, height is going to be equal to 56.03 plus 9.35 times by 10. So let's put that into a calculator. So I'm going to type over here 56.03 plus bracket 9.35 multiplied by, where's the multiplication? Multiplied by 10, close bracket, hit the enter. Therefore, that is going to be height. So the height is going to be equal to 149.53. Make sure you include units, centimeters. So let's just check whether our answers is correct with the back of the book. 149.53. Perfect. So that we got the question correct for question 3. For question 4, it's going to be the exact same thing. So I would like you to follow the steps that I've just conducted for question 3 to get the answers for questions 4, 5, and 6. And lastly, for question 7, it's going to be pretty much the exact same thing as all the questions we've done all put together. So the first question wants you to find the equation. So again, identify what is the explanatory variable, what is the response variable, put into the Excel sheet to find out what is your the equation. And then afterwards, it says, what is the rate? Remember, the rate refers to the gradient. So in this case, it's going to be the number in front of x. So whatever b is, that's going to be the answer for part B. And make sure you do include the correct units. So I'm just going to help you out for this over here. We need to first identify what is the explanatory variable. So in this case over here, the day of the experiment will influence how much red blood cell count you have. So this is the explanatory, and this is your response variable. Apologize for my ugly handwriting. So therefore, that's your x, that's your y. Remember, we said that the formula to calculate the gradient was y2 minus y1 over x2 minus x1. Y in this case represents the red blood cell count. So in this case, I'll just say red blood cell. That's kind of the units in this case over here. And the units for the x in this case is the number of days. So therefore, your unit, let's say whatever, if you got an answer of 10, it would be 10 red blood cell per day in this case. So that would be your unit. Hopefully this video was a lot more helpful for you guys to actually answer the textbook questions. If you do have any other questions, please do not hesitate to email me. I'll see you again in the next video. Bye.